And good evening, everybody. Welcome back into the Dragon's Den. How are you guys doing today, guys and gals? Hello, Mr. Wizix, Pez Liz, Creatix Brit. How you doing? Glad to see you guys here. Um, so if you followed the last stream, you'll know that we took the box turtle apart. Okay, we didn't take the red and orange one apart yet. That's still sitting over here. We took the blue and white one, which was the first one I built. The files have been modified several times over since I built that one. And what I found out through some of the troubleshooting we were having, because these spool motors weren't catching and running, was I think a couple of things. One is I had reamed out my 24 tooth spur gears. And I think when I did that, what I was getting on some of them was the it's trying to engage the spur gear and it can rotate on my shafts. So the gear was still moving, but it wasn't moving the rollers because the gear itself could rotate on the shaft. So that was probably that was my fault, because I did ream these to size versus trying to just press fit them in. The other thing that I did was on the wheels. You'll notice these are different wheels. These are the newer style where the blue part is all one piece. What I had done was on the center, I had reamed the main thickness part of the wheel, and then on the end piece I didn't, so it was still grabbing onto the very tip. Well, the problem is that means the outer part can slide with it, but once again I reamed the inner part might be slipping around versus catching and rotating with the shaft. So we've reprinted the parts, and let me flip to an overhead view. There's a couple of things I want you to notice about the geometries here. Yeah, so once again, the old wheel, two parts. You had a sleeve that you went in, and then this went around. So what I did was I reamed this hole out to 8 millimeters, did not ream this one, so it definitely press fit into the end. But the problem is the end can catch now, but the wheel, so the end's rotating, but the wheel's not, right? You also notice that this is like a full plastic rim there. On the new wheels, the blue part is all one piece. The black part slides over it, and it's got an inner rib. If you've built a not a death racer, you built a dragster, you'll know that there's a V-shaped groove on these wheels. And I went ahead and installed this off camera just because it's a bit of a pain in the butt still. But you'll see that the blue plastic creates the outer edge, and there's a little bit of a rim on the TPU part here that will keep it from riding up on the inside. And then also on the inside here, you see how there's some spacing in the inner ring there. That is so that you can do that press fit and it will open up. It's got a little bit of room that it can open up some to fit on your shafts. These are a couple of slight changes. The other thing that you may notice, and if you can see here, this area right here is heat sets that I have recovered and not reused yet. Okay. These parts have been dramatically re-engineered to reduce the overall BOM and screw requirements. So when we mounted these, there was a screw that went through each side. And this is to screw it to the main centerpiece now. like that. So there's one screw on each side. There used to be 2 heat set inserts because we would set this in a lane and the heat sets would come through. That's now been changed. There's going to be heat sets here. So we're going to screw this. We're going to be able to set this right in the lane and then screw into it. So I do need to still add some more heat sets down here that I didn't notice real fast. I was trying to get a bunch of the heat sets done before the stream. The extruders, I was hoping to be able to reuse the extruders. Well, I'm not going to be able to reuse the extruders as a whole. You'll notice on this extruder, we still have the 2 halves, right? But mounting wise, we go from 2 at the front, 2 in the back, 4 total, to one on the front, 1 on the back. So we will have different mounting holes and different mounting locations. So I do have to rebuild these extruders. The idlers will be the same, so they'll drop over. I need to do a couple of more heat sets because I need to do the heat set in the top of these. I already got the heat sets on the 4 sides and the one here. This will be to hold the idler door in place. But I need to do the heat set in the top on all 4 of these, and then the ones in the bottoms here, so we'll be able to mount those. So let me do those real fast. And then hopefully we'll be able to get into putting things together. There was also several changes to the lights and how the lights mount. So it reduced, we won't be using the little number 2 or the M2x8 screws. So we no longer have screws coming through the top of this. So that gets rid of our flathead screws. It's going to basically have tabs that will clip in and rest in place. And then our LEDs, we'll put our LEDs in here kind of like we did before. And then this is going to, one way or the other, I haven't really paid attention. Yeah. We'll get our LED in there, and then it's going to go in there and clip down underneath there. So it's a tight fit. It does clip. So that's going to be a couple of more changes that makes life a little bit easier. So we're heated up. We need to do a few more heat set inserts. Let me go ahead and do the extruders real fast. That's probably where I'll start, is swapping these out. And once again, we didn't have any real issues with the extruders. The issues we were having was with the respooler motors. But because I'm going to the latest version of the tool head design, I really have to go through and redo the extruders because of the way it mounts to the lane. So it's one of those cascading change things. Hey, Timor, how's it going? Modlight, welcome in. Modlight, your last set of prints was done over here on the rat rig. So I will be trying to get that out to you this weekend. Not gonna lie, I'm starting to freak out a little bit. Mrs. Dragon will be here Saturday, which is what, 2 days? So I gotta do a few things around the house before she gets home. Hopefully we don't need to change any of the wiring, right? So what I did with our motors and such, I did disassemble everything, but I tried to just loop the end stop and the motors together so that we can just reroute the wiring. The end stop mount changes rather than being captive in there. The mounts are more coming from the side. So I'll show you those when we get there. And I don't think I'm getting these off. We had to press these on using our Nipix. So I did not reprint the 10 tooth gears because Yeah, if they're trash, I'll just reprint them and redo them because there's no way I'm getting those off without bending the shafts on those N20 motors. Um, the other major change that you'll notice is when I show you the lane here, so we used to have 4 mounting holes. We now just have the 2 for the new extruders. The fronts here, rather than coming in the sides on both sides, these pieces are now going to slide in flush, and then we're going to screw down through the top. And then this center hole is going to be our PTFE tube. So I'm assuming I'm probably going to have to put an ECAS in there. And then on your spool holders, you'll notice we don't have that little ribbed feature in the front. We've got these scalloped depressions on the side. We've now got our new rollers that are going to sit in there. Okay, and we're going to put some more of the MR148ZZ. We're going to use these bearings. So if I remember right, that was the only place where we used 608 bearings. So that took another part completely out of the equation. So we won't need the 608 bearings in the build. So there's some goodness here, and we should be able to build this faster because we don't have to redo any wiring just to get up and running. And I can redo some wiring, I'll say, at my leisure for things like quick disconnects for the LED lights and things like that. But with any luck, we should be able to make some good progress today in getting this built back up. And if we can at least get it built back up today, then we may do a stream tomorrow, if not Saturday. Well, we're definitely streaming Saturday morning before I have to go pick up Mrs. Dragon, but we may stream some tomorrow night just to play around with trying to bench test everything because I don't want to assemble the frame until I've bench tested the component. Right. Left the electronics pile here all pretty much so that we can just cable everything back up and we'll do a bench test just to make sure that things are moving and doing what they're supposed to. So how's everybody doing today? Hope everyone's week is going well. I did have one bearing that was stuck on here, and when I got it off, which was, using nip picks to hold around the shaft and beating on the shaft with a hammer, or not a hammer, but a screwdriver. Yeah, the bearing developed a crunchy thing, and that's why you want to make sure that you're fully supporting on the raceways. But there was some damage on the raceways, so that it was then crunchy. So just replace it. I've got more of these bearings on their way in, both from a an Amazon order as well as a AliExpress order. So that'll be good. Two things that were loads of fun. One, if you can get a screwdriver underneath the lip, you can pull your ECAS out. This one, I couldn't get the screwdriver up underneath, so I'm just going to use a different one. And then the magnets. I'll use a different magnet for now on these, but what I will do is where the heat sets used to be, I'm going to drill all the way through it and then maybe be able to pry it or break it loose from the backside because these were super glued in. So you may have to do some work to get some of these back apart. Same thing with the ECAS fittings here. It may be worthwhile since I have a bunch just to put new ECAS in today, and then I can recover these off stream later. I think, yeah, I think I'm good, and we can start putting things back together. I say that. Let me, screw goes in there, ECAS goes in there. Got the heat sets in there. There's heat sets in the bottom of these. No other heat sets required here. We've got those. We've got our tool to use to put those in place. I've got two spacers. I had to reprint these spacers. And I've got to ask my Bamboo X1 folks. I went to remove the plate rather than try and pry the parts off the plate. And the plate had cooled, and as you know, parts will shift on a PEI bed. And I'm missing two of those spacers. And apparently just trying to print spacers, it didn't like. The good news is I at least got two, which is fine because that's what I needed. I have a feeling two of these fell into the back where the where the back lead screw is. So I think it may be in the back part of the case because I'll be darned if I can find them. Either that or they're on the floor somewhere over here, which means they're gone. So I think we're good. Yeah, so we've recovered a lot of heat sets. We're going to recover a lot more when I take apart the extruders and recover the heat sets out of there. So we're using a lot less heat sets. We're going to be using a lot less screws because we're using less heat sets. So that's all good. Hey, Reverend. And the other thing that I'll do is show you guys this. So for those of you that have been asking, yes, there is an enclosure planned. It looks like this is a full length extrusion, which I don't necessarily understand why you would use a full length extrusion there for the enclosure, because how do you open it up? That is the back, there's the front. Once again, that would be a full length extrusion. So I don't get it unless this panel like just flips up and I'm just not seeing it yet. But for right now, frame or not enclosure. Make that go. There we go. There's box turtle. There's our box turtle. There is an option to print the lanes with the logo embedded. And you can just do it with an inlay, or you can do it multicolor and have the box turtle logo be multicolor. But you can see now how your spools will sit in here. and our spools are multi-part. So we've got two pieces. They're exactly the same. You'll print these, and then you'll print these little screws. They've got a D-flat to them. You'll screw this in one side, just like that. Then you'll come in with the other side and screw that on. And there's your roller. You just need to press your bearings onto the end, and then you'll have your roller. So that part's pretty easy and cool now. Said I wanted to start with the extruders, so let me move these parts over here, and then we'll get started taking apart the old extruders, and we're just going to do them one at a time. We'll take one apart and rebuild it. Trying to make some room here. And as far as the frame goes, we will redo the frame last. I want to make sure that we can get the mechanical parts in and bench test, especially those head units, before we go and do the rebuild. I think it'll just be a safer way of doing it. And then also, one of the things that I don't think we're going to have to redo, based on what I saw, are these. I think these are 100% the same, these levers. So if anybody knows if this changed, if any of the guys from the team are here, please let me know. I've got them printed out. They're just in a bag over there because really I can get everything out of there, but the ECAS is going to be a pain in the butt, and the magnets will be. Hey Jedi Spidey, how's it going? One-time box. You lock your favorite filament in there and use it sparingly. Exactly. Exactly. So I left all of my wiring here. We should be able to take this apart, I believe, without having to remove a bunch of wiring. Ooh. Yeah, it's going to be interesting getting the end stop out. So should be able to reuse the idlers. So that's not going to be an issue. There is a new, there are some new parts for the frame that allow you to run. They made some parts easier to run lights. I'm not going to run lights on mine other than the lane lights, so that's no big deal to me. But there will be options for lane lights, which, I do understand that, that makes the printer go burr faster. I get it. But I'm trying to get functionality now. We can work on bling later. And if this works, then I'll be trying to reprint all the parts for the other box turtle, provided I have enough of the Galaxy Red and Galaxy Gray to do so. So if I can get it twisted and get it down through there, then I'll be able to reuse the, or not reuse, but I'll be able to keep the wiring in place without having to take it apart. Otherwise, I'll have to take it apart. I can reuse the existing frame, but if I want to, I was going to say, my understanding is they have changed some of the geometry on the frame. So if you really want to, like me, I've got an option. I can reprint the frame like I did for the red and orange build in order to, oh God, English sometimes, in order to make it that nice mesh frame. Otherwise, I'm going to have to reprint the whole frame to the new geometry. Just kind of what you want to do. So TechJeeper, here's the issue. I'm having issues with my, come out nicely. There we go. I'm having issues with my head motors, and I wanted to go to the latest and greatest version of the files because there's some good changes that I think will make some, some quality of life changes that will make things easier. The problem is, in doing that, I just lost my ball and I am going to have to cut that out. In doing that, all of the geometry changed on the on that top head, which means if you're going to change the top head, you have to change the lane because the whole mounting mechanism changed. And you have to redo the extruders because we're going from a 4 mounting hole pattern to a 2 mounting hole pattern, which means less heat sets and less screws. So yeah, unfortunately, one change cascades into many. This is one part of being in a beta group, is sometimes you have to reprint and rebuild. Like, I can tell you right now, the 2 that I have different parts. The second one was built using a different version than this one was built with. But it'll be the same thing. If I want to change the head, there will be a few things that I've got to change out. Okay, what I'm going to do is I'm pulling, oh God, get through there without making me, all right, good. I thought it was going to make me have to cut that, and I was going to cry a little bit. So now I need to feed this connector back through there. But yeah, it's more of parts compatibility, and like I said, the changes that they've made are to reduce the BOM, which means less things that you have to buy. Like, we're doing away, the new idler design here does away with 608 bearings altogether. So you wind up requiring just 2 types of bearings. I think they're the MR148ZZ, I think is the way. And so we get rid of those, and we get rid of, what are the other ones that we get rid of? Or no, we'll wind up just having those and the tiny ones that go in the tool head. The nice thing is all of those are recoverable rather easily. So, and these little blue holders for the end stops here are the same. So you don't have to, like, these pieces right here are the same. They didn't change. The geometry of the extruder didn't really change. It's just the mounting lugs to reduce the number of heat sets and screws. So that's going to be the interesting part, is at the end of this to see how many screws and heat sets we're able to recover and have left over. was about to freak out thinking that was cracked, but that's just a bit of filament. All right, so this comes off the back motor mount. Good, that in there nicely. Nice, good. Make sure we get our motor going in the same orientation, which is your wire needs to be coming up where this little bulge out is. If it doesn't, then it's underneath the motor and you can't do maintenance on it without having to take the whole thing, which is, as you can see, not a small amount of work. And once again, we're going to bring this up and mesh it into the plastic gear, and then just make sure that we're able to move it. So I don't know if you can tell there, but that's backlash. That's backlash in the. So you want to increase the rotation in to reduce the amount of backlash. You don't want it binding, but you don't want a lot of backlash. Once you get that backlash out, now you can tighten down your screws. There you go. So new part, new part. Make them sing happily together. Getting the bearing lined up. Pushing it together. Our alignment for our filament is still good. You can re-verify that and change it if need be. So now we just need to put 4 screws in again to lock this together. And these are all M3 by 8s. And I will say that Robert and the crew have been very responsive, and they've listened to a lot of the feedback that are coming from us. I mean, they've built them. We've built, a lot of us have built these now, and we're working through some of these issues that we're having. But there's little quality of life things like, yes, we redid the lanes and made the idlers easier, reduced the bomb. Which got rid of a lot of heat sets and screws as well. Okay, little things. So on this part here, you'll notice it's nice and smooth right here. Right here, you'll see that we now have 2 slots. That's for strain relief. That way we can put a little bit of a loop here for strain relief as we do the wiring. Very simple things like that make the build so much nicer. And the fact that, on some of these things, like I was making comments and Armored Turtle was sitting there making changes on the fly. And I'm looking for the zip ties. I'm telling you, I move things. I have to be digging around looking at thousands of darn. But apparently we're going to. Bag of them around here. And how's it going, Thunder Keys? Welcome on in. Thunder Keys is the one that got me into this, so I'm going to blame him for everything. My wife complains that I've got more builds going on and I'm not getting rid of printers. I'll just be like, well, Thunder Keys got me into a thing, and you know, I could not do a beta test. I mean, come on. Yeah, we did the nice new parts. We'll have to find my zip ties though, because these need to be zip tied back together. There is a like, I'm looking at ways of making it a little bit easier, because like right now the way I had it before is, in order to take lane 4 out, I had to take all the extruders out to get to lane 4 to be able to remove the wiring easier. There's a part of me that says, why don't I do like a 2x3 disconnect, microfit disconnect here, because I'll need 6 wires, and that way I just cut the wire here, add in, you know, do the crimps, and I have a quick disconnect, so I can disconnect and remove a lane. But then again, if you're removing a lane, you're having to open the frame up anyhow. So another option that I have printed out here is, you'll see we don't have the extra hardware here. So there used to be 2 heat sets here and 2 heat sets here to hold on these nubbins. That was another one of our suggestions, is making these print in place with supports. So now you have options. You have no supports, which means you'll have to print these pieces separately, add the additional hardware to mount them. You've got this one here, which is supported nubs, mounting nubs with no logo. And then you've got the one with the inlay inside that's designed for multicolor. So a lot of changes. And like I said, a lot of these are really good changes. Really like how he has worked with us and made some of these changes on the fly. And I'm going to hold off on that for now, because I may actually do it to the lanes themselves. So we've got that done. Like I said, the idler to be able to go right back in here using the same exact hardware. So that's nice. Just remember, when you screw down this, that this is a pivot joint, so don't crank down on it, because you'll compress the 2 parts together here, and your idler door won't be able to open up for maintenance. And then we'll have to put the ECAS fittings in here, because I'm not going to try and dig those out on stream. I will just put new ECAS fittings. And yeah, Thunder Keys, I figured I was going to have to reprint the parts, or some parts. So I might as well just update all the way for now. Because this gets, you know, if you're going to reprint the head, then you have to reprint the lane. If you reprint the lane, you have to reprint the extruder, because it goes from 4 to 2 for mounting. So it's kind of like a cascade daisy chain effect. And like I said, I'll put ECASs in these all at once afterwards. So for now, we'll just swap the parts in these extruders. How's it going, Tech Jeeper? Like I said, I didn't have to tear it all down, but if I'm going to be reprinting parts to replace a bunch of the parts in the head, I might as well upgrade to the latest version of the parts. So I'm not sitting here having to say, oh, I'm having issues, I'm having issues. Well, what version of the printed parts are you using? You know, is kind of where you get at. You know, like on the software side, it's okay, what version of Python are you using? Are you using 2 or 3? Which version of Python? And even more so, what version or what's the version of Clipper that you have? So I have found anything above 29, was it 290? I started having, was it time too close issues? And so it's a timing issue, but I believe it's in the Python code internal on the Clipper side. So as soon as I rolled it back, that timing error went away, which drove me insane because I fiddled with it for like 3.5 hours before I finally did that. So yeah, I reprinted I got more filament in this color and I reprinted all these. So this is filament that I still can't talk about, but by doing these parts that way, it will allow me to, if I want to, I can reuse the skirts without making any changes to the skirts. If you're going to reprint the skirts with the latest versions, however, then you are redoing all the skirts and you're redoing your hub, which has 5 ECAS fittings in it and a sensor. Because my understanding, I think it was you, Tech Jeeper, that told me that Tech Jeeper, somebody told me that the skirts are thinner in the latest iteration. Okay, so that came out. Once again, we'll do recovery on these. So I need to take this and, sure, set it over there. Grab a new one of these and we'll just get this inserted back in there. Good. Mount your motor. Once again, making sure that your wires are coming up towards the tip, not downward. Downward dog here would be bad. Hey, Big Jano, how's it going? Welcome on in, my friend. Welcome on in. So once again, you can be meshed like that right there. And I don't know if you can tell, but look at how much wiggle I have. That's backlash in the system. You don't want that. So rotate this motor in a little bit more. Don't like really crank it in there because then you'll have a bind. But I like to push it in, relieve my pressure on my finger back here, then rotate it. And that will take out the backlash, right? So no more backlash in the system, and it doesn't let it pull all the way out. Now I can tighten this screw down, double check that no backlash got in and I'm not binding. Because this screw, the way it's turning, as it clamps, it has a tendency to want to move outward. That's why you got to leave your finger there to hold it in place. We need to get our zip tie in here so we can do our strain relief on the wire. I might as well do it now. Wires in zip tie. And once again, we're just gonna take and kind of push that up a little bit so that we'll have some good strain relief at this end. Down. Now I've got good strain relief. If we need to undo this, we can without causing ourselves some issues. Now we need to take our end stop out of here. And the trick here is we're trying to remove the screws from the white plastic. Once we feel that tension change, we should be able to reach down there, grab hold of those screws and pull that piece out, right? So that way, here, background that's not black, right? Aren't it? So we have these screws still in there. We'll take our end stop out. Don't forget about your ball bearing that's down in there. Otherwise, you'll be chasing it around the floor. Okay, we'll get another one of our bases here. We'll need to push our wires through. Get our ball bearing drop down in there. Get our end stop roughly in place. Put our little locking piece back in there with the screws still there. That way it'll hold our end stop in place and align it, and we can just screw these down. And these are screwing into plastic, through plastic, so just feel it bite. You're not trying to crank down on these, because if you do, you'll break the plastic retainer clip, and then you have a bad day. So now we're going to get these lined up. We still have the bearing there. I'm not going to bother taking it out. We just need to make sure that we get it lined up appropriately. Push it straight in like that. Now I can put in our 4 screws again. So how's it going, Jano? And hey, Dandelion, thank you for the follow. Appreciate it. Subs are nice. Follows are free and always appreciated. I do run ads, so if you like the content and you don't want ads, then, you know, Amazon Nitro or use your Prime sub. Get rid of ads. So now we've got our extruder put back together here. We'll have to redo our wire management, and I'm going to wait until we start installing it back in the lane. Add my idler back in here. Like I said, I'm not swapping the idler out. I'm just reusing that part because it is the same. It's one of the few things that change. Unfortunately, you do need, this is a button head cap screw, so you need a 2mm here. Make sure it still moves. And then everything else on here is a socket head cap screw. And quite honestly, there's no reason to use a button head cap screw there. So if you're using a socket head cap screw, at least it would be one less kind of tool change as you're trying to do this. There's 2 extruders rebuilt. There's a third one here. So for those of you joining, we're building a box turtle again. We just did a stream on building our red and orange box turtle, and it's working. I have successfully done a print, but it required me to manually interact with it throughout the whole print because the respool motors, which are these tiny N20 motors, were not working. And it wound up being like the motors are good. The issue was more of a mechanical one. Okay. And the way I assembled it. So I pulled my normal, which was I about started tightening this like I was done. I do my normal, which is okay, we're trying to fit things on a 8mm rod, right? Rod that we had to sand all these down to get them on the bearings. Well, then that's fine and dandy, but I went ahead and reamed the parts to make assembling the parts easier. And now I have some of the 24 tooth motors, or excuse me, 22 tooth gears. So these little 8 tooth, or excuse me, 10 tooth gears drive these 24 tooth gears. Well, if this is able to free spin on the shaft, then this is just going to be spinning this on the shaft, and the shaft's not going to move. And that's what's happening. So that's why I'm having to rebuild the heads. I decided to use the latest version of the printed parts when I rebuilt the head, which then means that I have to do the new lanes and the new extruders because we're going down from 4 mounting holes on the extruders to 2. The way that the respool motors and the trigger mount at the front is different. And once again, that reduces heat sets and M3x8 screws by a lot. And some M3x10s as well. So it kind of saves you on the amount of hardware and the different types of hardware that you have to use. So, and I will off stream later tonight, I will recover the heat set inserts out of these and also try and get the ECAS fittings out. Okay. That one's done. That one's done. Over there. Big channel. Doing well. Just finished getting your Super Racer Delta back up, running after getting it in some new PTFE couplers. Nice. Capricorn tube. Yeah, cap tubes always good. Cap tubes is always good. When you're putting these in stops back in, make sure you get your plungers on the side where the bearing is. Otherwise, it no worky. won't be able to get filament through because the bearing won't be able to push up, number one. And then number two, the bearing's going to, if you can get the bearing to push up, it's not going to be properly aligned and trigger the end stop. Which we're using these as simplified filament sensors in the extruder or in the extruders here. And the nice thing is that word something. It's a simple mechanism that's been used a lot, and it's the same exact mechanism that we're using in our Filometrics tool head. So, you know, it's a proven method of doing it. I really like it a lot. Don't do what I just did and push that bearing down on the shaft. Yeah, all we're doing here, Jano, is we're just taking apart and rebuilding this using the latest versions of the files so that we are... I needed to take it apart, and I was going to have to reprint parts for the Respool motors anyhow. So going ahead and updating the parts to the latest version is probably not a bad idea, because so many quality of life changes have been made, so many slight geometry changes have been made. So it just makes good sense to, I'm going to be reprinting parts, let's go in with all the goodness. And by keeping the wiring the same, and as long as I plug everything back into the right spot, which is why I'm trying to keep, why I'm doing these at the same time. You know, I'm taking one apart and rebuilding it. That way I keep the wiring the same combination between the extruder wiring and the end stop wiring, because I know that will work when I reassemble it. Same thing on the motors and the end stops. I've tried to keep the N20 motor and the end stop wires, when I took them apart, I wrapped them around each other like that, so that that makes a motor to end stop pairing. And based on the length, I'll be able to say which one goes on which lane. So that was my idea and thought process there, and so far it's worked. So hopefully with the new mounting of the end stops, which I don't see it affecting the needed length of cable, so we should be just as fine there. Okay, so there's the third one. We'll add the idler back in. And then, like I said, I'll just put new ECAS fittings in these. Once I get all 4 of them built, I'll go through and do the ECAS fittings. and I'll dig out the ECAS fittings and the heat sets from the original extruders after stream. And the way I do my extruders is I tighten them down, don't like crank, but I tighten them down, and then it's one full turn off, and that should be the initial starting point tension to work with. On our lighting, like I said, I'm going to try and mount my lights the exact same way with the continuous daisy chain. And then off stream, as a quality of life thing, once we get it done, I may be looking at like making the extruder wiring here a little more, I'll say, plug and play. So kind of get it here like this, do a 2x3 microfit connector on this end, and then a matching connector on this end, so it becomes a quick disconnect. If I'm ever working on a lane, I can disconnect everything at the lane and take the whole lane apart without any issues. One of the other quality of life things I'm thinking of doing. And if you have that done and you have an issue, you burn a motor, you can easily build a new extruder and just do a hot swap of the extruder. Now you have time to build this, fix this on the bench, which is always something nice. One of the things I like about the stealth burner is your ability to take off 4 screws and you can pretty much, unhook a couple of wires and it comes right off. And you can take it to the bench and work on it. Because I know some of these commercial machines, like, it's almost like they put it together for factory only maintenance. They never ever anticipated anybody else having to take this sucker apart. And honestly, I don't think they expected to take it apart themselves, because if it's that much of a pain in the butt for us to get apart, it's got to be just as much of a pain in the butt for the factory to take apart if they ever have to, if they get a return and they've got to refurbish it and stuff like that to try and resell it. Okay, so that's back in there. We need to this. Once again, when you're pushing this back on there, make sure you've got good force on the wheel. That makes sure that you've got good contact around the bearing. Be careful not to push this bearing down on the shaft because you want it to be extended out to go on the back in the slot here. Or you can take that bearing off, push it back down in there. For now, I'm just trying to work it this way. I think it's a little bit faster. And I should know this, but Jenna, you've got a table at 3D Printopia, right? You don't this year. Oh, okay. This is going to be a walk around show then. Have a chance to walk around, say hello, and chat with everybody. Which, unless she gets tied to a table this year for some reason, just hang out with Pez Liz. She will introduce you to everybody at the show. Good way to learn new people and faces. She is such a social butterfly, and she seems to know everybody from running MakerDeck and everything for years. So she runs around. She was introducing me to people left and right last year. Like, you really think my mind's going to remember that? Like, too many names, too many people. Okay, so that's reassembled. We need to do our zip tie for good measure. Figured that would get a response out of Liz. You'll be a squatter at all the tables? Cool. I'm up on the upper deck. They got it listed under my name, which is Luke Ingerman. If you see, once they publish the map, which I can't remember if they published the map for real yet or not. But if you see the Dragon Den, that is Dragon Den 3D printing. That is the young lady that was also at Midwest Rep Rap Festival. She designs and prints dragons. So I cannot begrudge her. I just need to make sure that you all know when I refer to the Dragon Den, it is this physical studio space, not her company. Need a Plinko shift from you. There you go. Map is public. Okay, good. And Thunder Keys, have we published a version of the map that shows where box turtles are going to be at? I know we have one listed internally. So once again, tighten it down, then one full screw or one full turn. That's a good initial spot for tension settings. And I'll try and recover the ECAS fittings for now. And the heat sets for now, we're just going to build new ECAS fittings and put them in place. I think it'll be easier that way. I say that, like, when has it ever been easier that way? Like, oh, this will be easy. No, it won't. I need a place to sit those because I'm getting old man issues. We'll just call it that. The joints are creaking. Uh-oh. Oh. Thank you, Alexa, for telling me that rain's possible. The forecast has been telling me that for 4 days. Oh. Okay, folks, I'm going to be right back. I need to go downstairs because I think the other package of bearings just got delivered. So bear with me. I'll be right back. Yeah, so we got more bearings, which is always good to have. And a knife. Something else that will prove beneficial. So this way I don't have to jury rig a crazy setup with an LM2596 whatever buck converter. We got a new shiny. It's going to be a bench top. This is a 30 volt 10 amp max benchtop power supply that we'll be able to use to do certain things. It also has USB A and C charging port capability on it. So we'll have this as part of our test rig setup for the channel, which, like I said, will come in handy probably on whatever the next stream is as we go to test out our N20 motors that are running at 6 volt. Okay. Sit down here, grab some coffee. I just figured out this is like this old Tony Talking Hands video. Hi, everybody. It was probably better when you couldn't see me fully, huh? Make sure you take the little rubber donut off, but make sure that you still have that little black ring at the bottom. If you don't, your ECAS won't work right because that's what captures on to the ETFE tube. And I'm going to use my Nipix pliers to squeeze the blue part into the other part. We're going to need several of these. We're going to need 8 for our extruders. I think I'll need at least one more that I wasn't able to get out of one of the other parts. Try and recover that through, you know, part destruction capability. You know what? I tell you what, Chris at KB3D got me a set um, in preparation for the black box build, and I don't know how I ever lived without these. These things are amazing. And the weird thing is I don't know what the rubber piece is used for. Every instance where I have used ECAS, whether it's on a Voron printer build or the ERCFA build or whatnot, tells you to take the rubber donut off. And I guess it's to save distance within the part, right? As maybe a space saving measure. I don't know. All right, 2, 4. So that's the original 8. I have 3 of the 4 up here for the tool heads, so we'll do one more. I'll be tossed up there for use in building the tool head, and building the respooler heads. I'll put that one there. I have a feeling, and I'm going to have to look at, we'll just do a couple of more. I have a feeling on the lanes that we have another ECAS fitting at the bottom of it, but I'm not 100%. Not sure if the PTFE tube just goes straight through it, but while I have this out, might as well do a couple of more of these. It's not like it's going to take us a lot of time. This could be a chat and chill stream, right? We just sit here and chat and go through and prep NIPICs, or not NIPICs. We go through and prep ECAS connectors. We go through and remove heat sets, recover parts. Right, there would be the potential other 4 that I may or may not need. I don't know yet. Somewhere I've got a little baggie that's got all of these rubber donuts just in case I actually do need to put them back on things. For now, we'll toss them over there. Okay, so we need to get our thingamabobbers in here. What I try and do is get it started a little bit so it stays in there. And then we need to go down on our bench top where we've got a solid edge here. I'm like, why isn't that working the way it did before? Because I don't have my tool thing in here. So I'm going to use the edge of my bench as a straight edge so I can push down firmly on this. Because we got to miss the lugs. So you need something with a good 90-degree angle. And this has kind of a rounded edge to it, so it's hard to use this. But if you got like your build surface, like I build my frames on that quartz countertop, you can use that. And your goal is to get those fully seated and make sure they still do their little compression function. If you get these in and they don't do the little pneumatic compression function, well, you get practice digging them out. Hopefully without busting the part or marring it up too much. Okay, so there are the 4 extruders done. The ECAS fittings put, if I can get it, there's dents in here now from the ECAS fit. Oh, that's funny. Sort of. I guess we might as well mount these on here and that'll help us get them out of the way. Just going to position them on here and mount them. Let me rethink this real fast. These are the heads, these are the front. Yeah. Motors go, your head of the motor goes away from you, and then the head inject goes away from you, and then this is the right-hand side. Do these lanes get, before I do that, because it'll make it a pain to do this afterward, I'm going to look at the CAD. Okay, so good thing is we'll have the ECAS fittings we put underneath here, so that's still the same. What is this middle hole here? Because these 2 are screws that go in, but what is that middle hole there? Because that's too big to be. Oh, okay. I got you. So that's access. So that's going to be an access hole to this screw. Where, yeah, so this is a gearbox cover. Your N20 motor sits in here. This will clip on top of it. So if you need to get to the motor, that will be a way to get to this screw and undo it. So it's just an access screw. Okay. That makes sense. So we are good to go ahead and mount our extruders on here. Just be able to get something else out of the pile off the desk here. And I did notice when I was printing these out, that the I don't know if I can get it to see, but there are cable management slots down in each one of the rows. So we'll have a spot where we can like bring this up and then zip tie it to the lane, like right there. And that's where I was saying, you know, being able to build like jumpers and stuff like that should be a very workable thing. Jumpers, quick connects, quick disconnect. Hey, Armored Turtle, how's it going? Oh yeah, well when you have two bamboos going, I had one that was printing all of the lanes, and then once the lanes were done, it did another full plate of white parts. The other one did all the blue accent parts, and then started doing the white plates. Oh crap, I don't want to do that either because I need to route all the wires. I don't want to mount all these just yet, darn it. All right, let's start working on the full rewinders. We'll hold off on mounting those until we're ready to put it together in the frame. Nice. Okay, so we got all the tool head stuff apart. We're going to have our 24 tooth gears. Once again, I learned my lesson. I did not ream my 24 tooth gears. I'll say that again. I did not ream my 24 tooth gears. I did not ream the printed spacers either. So I went and grabbed the orange tool so it looks a little bit, it's easier to see. We're going to take our shaft, and it's most likely going to be a little bit harder to press fit in here because of this. Oh yeah, that's definitely going to be more difficult to get in there. Bear with me, folks. I'm going to go get my dead blow real fast from downstairs. Did I print the new there? I didn't reprint this. Did this change? Did this seriously change? I'm assuming it would be the depth that we're going to hammer this in. It did, but the old one will work. Okay. See, you're starting to scare me there. Let me grab my dead blow because I don't want to hit the top of that shaft with a metal hammer because it'll peen it over or potentially peen it over. Yeah. Want to use something like this, not something like this. Use this on here, you're going to mushroom over that end and you will have problems. Ask Shenanigans how that works out. But I am going to move this down onto the bench because if I do it up here, you'll hear every smack like a lot more than you would or should. And you'll hear the change in the sound when you get down in depth. That, and it'll, I don't know, physically stop moving. So the good news, Armored Turtle, is I didn't ream these 24 tooth gears out. So this will prevent it. What was happening was, I think the 10 tooth was making this move, but because I reamed it out, it's just free spinning on the shaft, right? And I'll say same thing with the motors. I'm going to go ahead and do this for all 4 shafts since I've got the stuff here now. Just make sure there's a flat side and a side with a lip. Side with the lip is up, because otherwise it doesn't sit flush. Or is the side with the lip down? Let me think about that real fast. Because this would be the inside, this would be the outside that's going to line up with the bearing. This should actually, the lip, yeah, the side with the lip is down. That's, see, I was thinking about it. So now I'm just going to have to, well, that's going to, it's moving. Very slow and hard, but it is moving. All right, we'll have to work on that. But yes. As soon as I was looking at it, I was like, oh yeah, that's got to interface with the bearing and be the standoff to the bearing. And then we'll have the, on the other side, we'll have the spacer. So one thing I might suggest is potentially putting a slight depression in here at the front ring so that it will be a little more indicative and it'll jog people's minds so they don't do like what I just did. Again, because I did that on every single one of mine, so that could be another problem as to why I'm getting binding issues. Or it might be already solved in the new tool, since I didn't download the new, or well, I've downloaded it, but I didn't print the new tool. All right, so there's 2. This is the one that we're going to have to figure out how to I think I know a way of doing it, which is, since I've got 2 of these 24 tooth tools, I just drill a hole completely through the bottom so I can continue to knock the shaft through the bottom of the tool and then come back in and reset it from the other direction. All right, so there's 3 good ones. This one needs to be changed. An 8mm shaft, so I need to drill through the bottom here with the 8mm, and that will allow me to knock that all the way through. There isn't the new tool. Okay, cool. And I know that's the one thing I did make a comment about earlier. I'm not sure if you were on here when I did, but you guys have been paying attention and making changes like very quickly. Very, very responsive to changes, comments, and the like. So that's really good, even on the software side as well, which is a little more painful sometimes. Okay, so once more, because I've got a second printed tool, what I'm going to do is I just drilled out the bottom of one, making it useless for setting that distance. However, what it will let me do now is push I'll be able to set this down in there like that, continue to hammer it through to move this down to this end. Then I can flip it back over in the other one and hammer it back down into place. So I promise I will fix my mistake. All right, so now I've got that knocked through. I can bring this flush down there. And there we go. Now we're fixed. And those are good and tight. I've got my wheels redone and got the TPU on there. Did the chamfer on the top of these kind of busted on every single one of mine. I'm just going to say, the closed side is the side that our gear is going to go into. And by closed side, I mean it's the closed pocket, the open pocket. This is where we had the tail end of the motor coming through. And our motors, we'll grab one at a time and we'll work on it. There are lined little cutouts and shafts down here that the motor lines up. It's this first plate of the gearbox will line up and slide down in there. Make sure you're lined up in the slot on both sides, and then press that motor down in there like that. That's going to help lock it in place, and then when you put the top piece in here, it's going to squish it down and hold it in place. There's your motor. Top piece being this piece. Got this little tab that fits in, and fit down there, M3x8 screw. Could be, huh? I guess that's changed. It's going to have to be an M3x10, I think. Either that or I just grabbed an M3x6. Like, grab the wrong screw. Yeah, that works when you use the right screw. So there's the initial head. I need to do the ECAS fitting in. Need to do that before we go too much farther. This would be the other place where I used my Knipex on the last build stream series. These we had to use the medium size. That was the medium size. Might have to go up even bigger. We use the bigger ones. We get out the big boys here. Be careful when you're doing this and go slow so you don't damage anything. When you're putting that Knipex in, I'm going to wait to put the, or when you're putting the ECAS in using Knipex, be careful. I'm going to wait to put the battery, God, English sometimes. I'm going to wait to put the magnet in the front because I'm not going to reprint these. Well, I have reprinted them, but I'm not going to tear these apart and redo them because I believe there's nothing that has changed in this part that I can tell. So my desire is not to change that if I do not have to. But what we do need to do before I forget is take one of our tiny, tiny bearings, put it back in there. We need another M3x8. That'll go through the printed part, through the bearing, into the other printed part. There we go, just like that. This goes through a side. Then through a wheel, and this is probably where we're going to have to do a little more hammering because I do not want to open those wheels up like I did the last time. Just bring it nice and flush. Everything still moves good. We also need to put one of our spacer sleeves on here, just like so. Now this piece slides through here and your motor is going to engage with the 24 tooth gear. Now, do you guys suggest putting any grease on those teeth? Like, have you guys been putting any grease on those teeth? Yeah, I like those. I actually do like those small bearings. I think that they work well. But like I said, have you guys been putting any grease on printed um, your printed gears to make them, or have you not had the need for it? It works so much better. And I just realized, hey, a motor wire came off. The other one is about to, so we're going to need to resolder that. So we're going to need to do that like post haste here before we go too much further. And I'm using 24 gauge for these. What have you guys been using for your N20 motors? Have you been using 24 gauge? Have you used... I know I made the comment about what wire gauge I was using, but I don't remember anybody piping up and saying, don't do that or do this. I need to fix that. Sorry, I'm going a little scatterbrained. My soldering iron that I wasn't planning on using today, so I stuck it somewhere. Which would be why I can't find it. Here's the solder. We'll need that. Soldering iron. Where for out there? Killing myself here. Move things around, and then I can't find them when I need them again. Not there, not there. You put some graphite on yours? Okay. I'm going to see how it does. I mean, I've got some standard super lube. I've got some 3-in-1 PTFE oil. I think I have some graphite spray for like doing garage doors and stuff. "24 on everything except the sensors. Those been using 26." Okay, cool. The long story short is I should be good with the way I've done these. See if I can clean the old wire piece off. So this is 24 gauge. This might actually be 20. This is um, motor wire, Steve. These like stepper motor wires. And I know if I can get this fully cleaned off, there are holes in there. Not going to be able to get the wire back through the holes now without doing a lot of really good cleanup. So we're going to be soldering directly to the pad. Nice. Here, good. Up. Okay. Those are back on there. I will go ahead and leave that stuff here in case I need to redo it again. So the wires, I was going to say come through here, but they do not come through here. We need to loop them around, and we've got our um, places to zip tie our wires here. And I just thought about it. The lighting wires are supposed to go through here, right? Is that what you guys are doing with them? Is routing the wires through here for the lights on the one side? So let me think through this because I still have my wires in one single row. I haven't, this is the way I originally done them up, and I was thinking about doing them as quick disconnects. Uh-oh, one of those came on too. That sucks. That's not going to be an easy one to try and fix that real fast. Should just be a touch up. Second soldering problem solved. Now is the time to make sure that spins nicely. Yes, so and are you saying to apply power to the end of this? And make sure that that is spinning. I am assuming that is the spinning that you were just referring to. Let me see. I don't want to do any soldering on, well, I don't want to do any more soldering. Let me see if how easy and intuitive this is to set up. Yeah, at least by hand, but if you can apply 6-volt to it, I'm going to try with 5-volt because that's what we would get if we were plugged in originally. Okay, so we want the output voltage. Sorry, I about removed that off screen. We're going to do the ASMR peel here. Really? The pull tab pulled off of it. All right, that's another day. So we want at 5 volts. And 2 amp max is what we're going to get out of if we're doing the board. I believe it was 2 amp max. Yeah, if you've got a benchtop power supply, since I got this and it just came in today, I figured why not give it a shot. Negative, positive. Oh, wires, come on. Negative alligator clip to the negative side. Positive over on the positive side. And we should get motor movement. So that it's connected. I don't have my output turned on, so if I turn on my output, we've got movement. Here, let me just going to put some tape on there. So this goes on in this direction. Yep. So moving in the right direction. Yeah, it's pulling 1.6 and 0.02 amp. So and mind you, I'm giving it full amps, right? I set it for the amps. So this is a good test. Motor works. We don't have any binding here now, so that's good. And I think that's what the issue was the gears were slipping because I had reamed out the gears there. So turn you off for the time being. We'll put you back down here. We'll grab you when we get the next one done. So we've made progress. We'll need to bring our wires up through here. And I'm kind of debating if I should try and cut and do the LED lane wires now or just put them in the way I had them before, which would mean taking it all apart again to cut the wires, add the new, add the connectors to them and route them down the right side. And is that the intended path now, is to route them down the right side and down along that channel in there? That's the only thing I can think of would be the LED wires down through there. And I guess technically I could route the wires through there now without adding the connectors, and I can add the connectors later on. I just thought because both the input and output are going to go through there. I just have to definitely, I'm just thinking through things right now in my head. I should be able to do that wiring afterwards. But I will want to take this off so I can, I'm going to have to build these basically all together with the wires for the lights in place. So we'll undo that one. We'll need to do the magnet on this, which means, where's my, the nice thing about having a metal workbench, I've got 6-3 magnets everywhere. So that's the correct orientation. So I flip it over, and that should be the way that one goes in. And there we just validated that that's in the correct orientation. So that's going to be there. We need our lights, and this is the longest motor wires with the shortest end stop. So this is lane 1. Lane 1 is closest to our connection to the board. So what we're going to want to do is lay these wires into the channel. And I don't know how long it'll need to be. We'll figure that out here in a second. Set this on there, make sure the wires aren't being pinched. That screw back in. Slide this side down on there. Being mindful of your wires up here. We do have good wire relief and routing there. You just need to be cognizant of where that relief is so that you don't kink your wire for your motor. Everything lines up. Another M3 by 8. So we've got that there. We'll do the end stop here in a minute. The LED cover just clips on, and that can clip on now, correct? Armored Turtle? JST PH should fit through there. Yeah. So once again, understand how your LED sits in there so that the wires can come through. Ah. Okay. That goes in there like that. And then the front edge kind of goes up there and then up the other way. How does this piece fit in there? Okay, you kind of have to take it in at an angle. How do these fit in together? I mean, I see where they should be clipping in and sliding in, but how would you ever get this into that racetrack there? Or is it just hard snap press fit down in there? That's the only thing that seems like it would do it. Yeah, there we go. So you just get one side in, then you have to press the kind of angle it like this to get the one side under the lip and then push down on the other side and it'll snap in. Let me see if so. The circular depression in here is the side that the light sits in with all the wires in the back. So this is where the light mounts, and then, or the LED PCB mounts, and all your, you should see all your solder joints in the back here. And there's angles to it that line up with this. So you're going to basically wedge one side down in there and then push the other side down. And there's little, I don't know, there's little ledges in there that'll hold it in place. So we've got that LED in there. So the pivot point for this, is this just a M3 pin now? And then this clips on either side of the M3 pin. And that'll clip on further back. I guess I could look at the CAD. I mean, there's a reason I brought the CAD up. Not being. Hide that. M3x8 screw on either side. Right? Yeah, so this just takes an M3x8 on either side and then sits down in there now. I got you. Threading into the plastic. Ah, and that would be why. So, and are these just printed, thread into the print? Because these go right on through. So I would have to, I did reprint these. I was trying to keep from having to redo these, but we'll have to redo these. Ah, and these moved away from ECAS fittings at the top as well. So are these just PTFE tubes straight down in? So is this just PTFE nubbing straight in? So we got rid of some ECAS fittings as well. That's not bad. We'll need to take the M3x8 screw with the bearing out. Got screwed back in. Once again, don't tighten it too much if the bearing doesn't move. Want that bearing to move. We're going to need a thing in there, so let's make sure we're going in the right orientation. Dang, I am going to have to super glue that in there, aren't I? Yep, that's pulling it straight out. Dang it. Well, you know, I'm curious because I am using a full stack of magnets. Just the one. I'm not sure if it would pull it out. So bearing that, 2 M3x8s threaded into the plastic. We'll have to figure out the right depth. Hey, Ram Online, how's it going? Okay. And my magnet came out, so I am going to have to super glue that magnet in. Oh. So what you up to, Ram? Hope you're doing well this evening. We are playing with Box Turtle. I decided I was having some mechanical issues, so to solve the mechanical issues, I was going to reprint some parts. And of course, you reprint one part, well, that requires you to reprint this other part and then this other part. And now we've like reprinted the entire lanes. So I was like, oh, I don't need to replace these. I can just use the old ones. Now you've got to replace them because they are a slightly different geometry and different mounting method. And rather than having an ECAS fitting at the top here like we do on the old ones, PTFE tube's just going to go straight in. So we've had these little changes here and there that are forcing us to really reevaluate every single one of the parts that we were using. Then our lights here are going to flip under the front and the top. We've got to line them up on the front. It's going to be a pretty tight fit. There we go. So we've got our lights coming in here. I will be able to see like which way each one of these is going. So I'll be able to snip these underneath later on and make the necessary change. I'm going to try and get that magnet to stay in place. Sit here and hold it and hopefully let that super glue set up. Otherwise, I'm going to have to take things apart again. Let that set up. The nice thing is this part can just slide straight down in there. Easy peasy lemon squeezy. We need to get the other wheel on the other side here. And this is going to require some percussive persuasion, most likely. Whoop, maybe not. Maybe not. Boom. There's our new streamlined tool head. Got our wires to our motor. We've got the wire coming down the other side for our lights. We'll still have our end stop to mount, but that mounts on the lane underneath. And we're trying to let our whatchamacallit set up. So meanwhile, I should be able to recover these magnets. I'm just going to have to break the part to do so. Which is, is what it is. We need an ECAS fitting at the bottom. We need a magnet in there. So we'll go ahead and get the ECAS fitting worked in there. We'll start getting the magnet glued in so it has some time to set up. Come on, dang it. Find a little bit ugga-dugga. There we go. ECAS fitting in. So letting that sit there. One of our new pieces. One of our old piece. So goes in this way. That one's a good press fit. That's staying in. We need to remove this bearing. We'll just pop it over onto the other part. Hey Shenanigans, how's it going? Hey there, Royal Nomi, how are you doing? We're working our way through the other, or rebuilding our box turtle, and we're checking things as we go. And all of the little moving of things, I did have the wires break off on this motor, so I had to resolder them. And I had one of the LED lights come undone. I need to see. Yeah, well, that went in there really good. So that goes in just straight now. We're using a set or a couple of M3x8s on each side to set down into the printed nose piece. And what I'm going to do is I'm just going to use this other one here to figure out how far down I turned it. Line up. Be in a pickle. It's a rough guesstimation. We'll fix it once we get we'll get it perfect once we get the parts installed. We're closer to being. Okay. New one. New one. New parts. Okay, so we're going to start off by grabbing our Need the next longest motor wire, next longest in-stop wire. This one. So this would be lane 2. So this would be next in line. And the reason I'm having to be picky on which lane I'm doing when is because I'm having to embed my LEDs as we're building. So we want to make sure and give it plenty of, or we need to build these heads in the same order. Otherwise, we may run into issues. Old piece. New piece. Second new piece. Coffee. Yeah, a lot of things have been changing, so that's good, and it's been changes for the better, or I say better. Uh, they should be changes for the better, yes. So a couple of things I had wrong when I did my first two builds is this part has a little nub on it. It's like a built-in washer. I had that facing on the inside. It should have been facing on the outside to interface with this bearing, which meant that my tooth alignment um, with the motor may have been slightly off. So that was part one. Part two was I reamed these gears out, which meant that I had a couple of the motors where as soon as the gear hit any type of resistance, like when it's trying to engage with the 10 tooth gear here, as soon as this applied resistance, the gear spun on the shaft. So the gear moved, the shaft didn't. So that was an issue. And crap. There we go. This one I just busted the wire on as well. So I'll need to resolder this wire. I'll do that once we get it put together some more. So we've got our shaft with our gear in the right orientation, pressed into the what'll be the right side of the housing. We're going to put a wheel on. This is a 2-part wheel instead of a 3-part wheel. So the center hub and the outer piece now are one big piece. And the TPU, it's still got a slant, kind of slant to the inside. This diameter is less than this diameter. But there's a beveled recess in the printed part and a matching V groove in the TPU belt. So that helps it lock in a little bit better. The other thing is you'll notice there's, it looks like there's some print defects in here where there's gaps. Whoops. Those are actually expansion slots. So that these will go on the shafts easier. Because what I did was I reamed this center part out and I didn't ream the end cap that went on. So the end cap, once again, was turning in some cases, but the inner shaft wasn't because there wasn't enough friction on my shafts here. Now there's going to be. We're going to have a solid friction fit. And I'm going to do some percussive persuasion here. To get that first wheel on. So that's on there and spinning. Okay. That's spinning well. Now we're going to need to get our motor down in here. And once again, there's tiny captive grooves in this part that this first metal part of the gear slides into. So get that lined up. And then your motor is going to be a press fit down in there. I'm going to have to solder that, but I will get to that here in a couple of minutes. Your top rotator piece flips on there, and we'll need an M3 by 8 to come up from the bottom. Lock that in, and this just compresses and holds that motor in place so that the motor stays in place, so when it tries to move the gear moves instead of the motor trying to rotate in the part. We'll get this installed there. Where we need to bring up the next light channel here. Let me see if that is now going to stay in place. Yep, not pulling out, so that's good. Here we go. That clipped on. So we're going to bring our next light over, and that needs to lay down in this channel. We'll add this in. We need to put our M3 by 8 screw in the side. And I'm having to build it this way because I don't have quick disconnects on the on my LEDs yet. I will be adding quick disconnects between the different lanes here at a later date. I'm going to do that off stream. But when I talk about quick disconnects is between each lane, I'll do a microfit 3 connector. So I can unplug it. It should be a 3-pin male to female. So that will make these modular. So each one of these will be separate and standalone. I could do the same thing for like the motor wires and the sensor pins. And this one's about to break off as well. I think I might just help it. And we'll resolder these. There we go. There's that one. Where's the other? And then stop. That's an supposed to be easy enough to find now. This one is blue and red. Red signifying hot, blue signifying cold. So red will be positive and the blue will be the negative for this particular motor. So all I need to do is just resolder these wires on there. I'm going to try and clean up some of the solder that's on the part right now, and see if I can't. So what I did originally was I took the wire. There's a small hole, and you can get the wire through there, and then I wrapped the wire around, and that's how I attached these originally. I doubt if I'm going to be able to get those wire pieces out, but I am going to try and just clean these up just a little bit. This should be good. So which side's positive? Positive is closest to me. This will be the negative. Negative we said was going to be the blue wire. And that wire ever so slightly. Aren't you? The old wire in here is causing me issues. I have to try and get the old wire out. All right, there's one side. Way more painful than it needed to be. Sorry, I'm not looking at chat either right now because I'm trying to focus on soldering. Yeah, it's in this case, it's the old wire that's getting in the way. See if that will help. Okay, maybe we got there that time. Bring these wires around, and we'll have strain relief in here, so we definitely want to get some strain relief going and use that. On these wires, they are so small and I'll say fragile. Kind of a pain in the butt. Yay. How's it going, Rodney Mac? Welcome on in. We are having fun. We're redoing our box turtle build. And this was the original box turtle build that I did. And I'm having to redo it. I was going to have to rebuild the respool motors, which is what I'm working on right now, anyhow, because of some assembly mistakes that I made. Right, this was all on me, and some decisions that I made to, you know, like reaming out the 24 tooth gears. Well, the problem is now the gear will spin on the shaft and it's not moving the shaft. So now I reprinted them and I press fit these in by percussive persuasion, using a dead blow. And this one's now turning perfectly fine when we apply voltage to it. We've got this one there. This is the LEDs for that side. What else do we need to do? Let's turn off the hot things so I don't burn myself. There's still zero guarantee that I won't burn myself. We'll have the other side panel here that will fit on. And you want to be careful. This does have cutouts for the wires and everything. That's why I loop the wires kind of up and around. So just be careful as you're putting it in that you don't tweak a wire as it comes up around the motor. Okay. There we go. Make sure everything's rotated properly in place. And you've got two like alignment tabs on each side to make sure that everything's lined up. We'll put another M3 by 8 screw through here. That doesn't seem to be catching, so I wonder if I grabbed another M3 by 6. It looks like an M3x8. Why is that not seeming to catch? Oh no, but it did that time. Okay, so we're good there. We're good there. We've got our LED coming up. The LEDs, sorry, just something looks, there we go, slightly amiss. Alignment-wise. So the LED comes up, and we're going to have this little back piece, and your LED sits in this round cutout. Your wires are coming out back, and we're going to take this, we're going to set it down in there. We're going to try and push one side under like that, and then push down on the other side, and that'll lock it in. So that's the visible alignment. And if everything lines up, you should hear a satisfying click as everything lines up into place. This is our other input side. We've got these two M3x8 screws on either side that are going to lock into these cavities. It's just going to friction fit down in there. Just like that. We'll push that down in the gap, make sure that our magnets are lining up. Bring our lights down, them in proper orientation. We've got tabs up here that are going to fit into these holes, and then the fronts are going to slide down at an angle and clip it in, kind of pull it in and clip it in. Pop in, and then you just kind of rotate it down and around. Making sure that your wires are not getting crimped while we're doing it. There we go. So that just snapped in. Now we've got second motor lined up there. Our lever works good. Lever's working good here. We've got good sound and mesh from our gears. We need to put the other wheel on. Should just be a press fit. Just like that. And what I want to do is we're going to take these two wires and we're going to do like we did before. And we're going to apply a little power to them via a 30 amp 5 volt power supply. I'm going to turn this back on. Does it remember my settings? Yes, 5 volt, 2 amp, so it remembered my settings. Our black wire, our ground wire for this particular motor was going to blue because blue is a colder color. So ground to blue. Our hot side goes to the red because, well, red is a hot color. get this plugged in with the alligator clips. I'm just clipping on the whatchamacallits, the barrels, so they're not touching. We're going to grab our piece of tape, stick it on that wheel so you guys can see what happens. And I'm going to click the output button. And our motor is turning. It's going this way, which is correct because it's going to force the spool to spool back up. So that's what I wasn't getting before. So that's what the whole purpose of doing this has been, is to get my motors working like that. And this is a brand new bench power supply. I just got it in the mail today. So far so good. It's been pretty cool. What's up next? Next, spool head. We're going to grab the right side. So the right side, you can tell it doesn't have any other openings over here. The left side has the opening for the rear side of the motor to stick through. So this is the right side. And I just realized I didn't put the spacer on there, but that's okay. It'll survive for right now. Try and mess with it. We're going to take this, flip it on there. We're going to take a wheel, flip it on there. This is the one you might have to do some percussive force on because you've got nothing to press against really. Just make sure that you don't go down any further than you have to. So right there, this spins freely. That means our bearing's doing its job. This channel right down here is where the wires for the lights are going to go. So we'll grab the wires for the next lights and just lay that into the channel. We'll have our next motor mount piece. A couple of things that we need to do. First off is get our bearing in here. I guess I'll be taking, I'm going to have to take the other motor apart anyhow because I didn't put that piece in here either. Oh, come on, Bill. Ah. Dang it. It figures I would do something like that. Yeah, progress. The downside is because I didn't put that bearing back in there. It won't trip the end stop because it won't have the distance to trip the end stop, I don't think. Dang it. Okay. I got it on the lever arm. I didn't get it on the motor. So right now, before we go any further, M3x8, you're going to grab one of the small bearings. I can't remember the size of, or the size of this really, really small bearing. And it's going to go down right here between these two pieces in that slot. Your M3 comes through and is going to capture that bearing. And between the bearing here and the bearing on the front lever arm, that is what will hold your, or move that lever up and trigger the lower end stop. So I need to get that on. I'm going to go ahead and do it on both of these so I don't forget again. Because I'm going to have to figure out how to take this one apart to do that. Hey, Maker Viking, how's it going? Welcome on in. Yeah, we've got two motors that are functioning now. So it was all issues with me and the way I assembled these. I have to admit, this is all caused by me, myself, and I. I did this to myself. Little black ring came off that one for some reason. Using a set of Nipix pliers to kind of trying to help me get my ECAS fitting to set in there rather than being a pickle and a pain. Here we go. So we have an ECAS, we have a bearing. We have a bearing, we need to add an ECAS to this one. ECAS added. Now we need to get our front magnets in. This is the old lever. I'm just trying to make sure I have the same polarity. So I know in which way to put these. I need to put a little bit of super glue on these. These have been pretty good tight press fit on the levers, not so much on these front pieces. So we got those done. I'm going to do the levers. So we're going to take this bearing off the lever. Is an M38 with the bearing through it. Put on one of the new levers. Okay. We're going to pull the tubing out of the top ECAS fitting. And we're going to set this aside, and I'm going to do some destructive collection to get the ECAS and the magnets out of that. The PTFE tube now is just a press fit down in here. Make sure it's fully seated down in there. We need to get a magnet, so we're going to figure out what polarity our magnet is in. Press fit that in there. Same thing for this side. I'm just going to verify which way that magnet goes. Press fit this one in there. Pull the bearing. I'm doing good. Hey, Pez Liz. yeah, I mean, this is, quite honestly, I mean, this is why I'm in. If I wanted to just print, right? Quite honestly, I'll get a bunch of bamboo printers, probably not even the X1 carbon. I would get a couple X1 carbons and then the rest would be like P1Ss. And I would just focus on printing things for people. But I like to do builds. And this is, you know, some of the frustration of doing a build, right? This is what it is. Okay, so the other thing we need to do is take a couple of M3x8 screws. And these are going to make the pivot points. And these are being threaded directly into the plastic. So we're just going to slide these or put these in here a little bit. And how these are going to fit in there is they're basically going to slot down in there like that. So you want them tight enough that there's not a lot of lateral play. It's going to help keep the top head there, but you don't want them tight that it causes problems. Because this is a pivot joint, it needs to pivot cleanly. That's good. We'll grab the other side. We're going to validate the other side. We should be able to eyeball it and get close. And that's too tight now, so back that off. All right, that gets in there. A bit tighter. We're looking for a good fit without a lot of play. We don't want it too tight that it's a, yeah. So that right there is good. There's not a lot of play there. So that's pretty good. So that's one new lever arm. We'll do the other one. Ugh. And I cannot believe that I put that motor together without doing it, because now I'm going to be hard pressed to get that taken back off. But I'm going to need to take it back off. Any tips or tricks, Armor Turtle, for getting those off? For pulling these wheels back off? Firm hands and a twist. Firm hands and a twist. Where's Bexy Beans? Because I'm sure there's a that's what she said joke in there. Firm hands and a twist. Okay. And when firm hands and a twist don't work, you test out your printed parts and see how solid your printed parts are and try and lever it off. Just be cognizant of the bearings and your solder joints and everything else. You don't want to cause more damage. I think if I can get it started, it might come off a little bit easier. Oh, oh yeah, exactly. Exactly. It's either, you're trying to find the Goldilocks. It needs to be just tight, but not too tight. And then we've also got the, I've had to sand every single one of these shafts because, well, like you said, they're to a spec. I don't know what that spec is, but they're not like, mil spec, quality spec. So I need to take this M3x8 screw out. One out. M3x8 screw out. I need to pry up my light. So it should be the opposite of what we did. We need to take out our lever because once again, we've got the screws holding the sides together. Now, I should be able to take this side piece off. Once again, being careful because you've got the wires for your motor right there in the side of the motor case. There we go. Now I should be able to get back in here and put that bearing in. So I need one more tiny bearing. We're going to slide it down in there. We're going to grab an M3x8. Make sure it's M3x8, not an M3x6. I don't know where the hell that came from, but I do know I used some M3x6s. They're not called out for, but I did use some because I was running out of M3x8s. And I was like, well, hell yeah, let me use one of these M3x6s. Okay, so problem averted. Now we'll put our lever back in place. We'll put our flat back out. We're going to put this back in place. It'll go down pretty easy until you get to your motor, and then it's just a tight fit at the motor. So just go slow. Make sure that your registration points back here are all lined up. Do that final push click. Make sure you didn't damage your wires. Grab our lever and put that in place. Grab the lever and put that back in place. Oh. This M3x8 back in. Our lights back on there. Nice. Three going there, 1, 2, 3 going there. So I just busted one of the I pulled a light wire off. So I'm going to have to, how best to do. Not going to be an easier, an easy way to solve that. That's going to be an off-stream resolution. Because that's going to get into cutting these wires to add in a connector point, and then I can pull this out, resolder this wire that came off. So I'll solve that way. This can go back on there. So 2, black wire comes over there. This is the next set of lights, so I'll go into lane 3. Lane 3, we're going to start building up. We need the the next longest end stop wire, the next shortest motor wires, and that one came off. So geez, my not the solder joints, it's breaking at the wire itself. So this is not an issue with my solder joints, it's the issue with the wire and how I had to loop it around once I had it in place. So we'll have to be fixing these well. Slide that in there, put this on 3x8. We've got our next side here ready to go. We need to bring our lights up and through that channel. Bring our geared motor down here. Actually, before I forget, we need to put, and I still forgot over there, I didn't put it back on. Dang it. We need to add the spacer shaft. I tell you what, fun days, huh? That one worked off a lot easier now. Second time was a charm on that one. Spacer on the shaft. Yeah, I think we're definitely going to want to have some good measurements for everybody on the wiring for the lights and the quick disconnect option set up for these. Levers still work. Now it feels, well, doesn't feel. This bearing is pushed out some. I think somehow it may not be fully seated down. So this is going to be loud. I'm going to bring it down here. Make sure this is fully seated again. Interesting. I think the issue is with the side one, side two. So this bearing got pushed out a little bit with that spacer in place. Either the spacer is not fully seated, which could be, or something just isn't right. We'll have to fix this, otherwise the wheel doesn't go on fully. That spacer looks to be fully seated on there. Yeah, so now I'm having some type of gap here, so that the spacer is fully up against the gear, but now I have some type of gap, and if I close that gap, it pushes this bearing out, which is going to cause it to be wider. And just make sure that this is fully seated. That's fully seated, that's fully seated. That's fully down on that gear. No, we'll try a different side piece, just for whatever reason, see if it's just picky about something. No, so right there, that spacer is like too long or something. Something's not lining up here, right? So Same size as that one. And these are all the same size. So if it's fully in here, that side's fully down. Something is weird. And these are all the newly printed parts, so it's not like I've mixed and matched parts. Yeah, and tightening that down, that it comes out just a little bit. Can you see that there? And it pushes this bearing out some. Oh no, we're gonna roll with it for now. So there's two done. Here's my third. Need to get our light wires in here. Need to grab our motor. Make sure that the gears line up. Wires go through the gap nicely. Put our M3 by 8 in. That's there. Extra wire keeps getting over here in my way. Over there. We need to do our little resolder job here. Okay. Like, why is it not working? Well, it helps to push the button and turn it on. If it gets hot, bet you it'll melt some solder. Blue one, I'm going to resolder. I'll try and just flip it over to the other side. It'll make it easier to route the wires. Is good. Second one here, and then we'll be done. But we'll be close to being done for this one. We'll double check it before we put it all together and make sure that we didn't miss anything this go around. Touched up our motor solder joints, making sure that I'm not cutting my wire, cutting the zip ties, because that would suck. We've got our light pulled through the one side. We've got our motor on there. We've got our, yeah, I'm wondering if I printed them from the same batch. I don't know why they would be like one, well, yeah, two of them should be from the first one and one from the other. I've got three of them that are all the same size, so I don't know why it's doing that. That is weird. But we've got our front bearing on here, so we don't have to worry about that. We've got our spacer on the shaft, so that's good. We're going to put the side back on here. And so this one's going all the way on there without that issue with it trying to push the bearing out. So there's something with this one. I think maybe the F's not far enough to, I don't know. There's something weird. Anyhow, we'll see if it flies. Okay, so we've got the side on. We need our front lever to put down in there. Seems a little tight, so I'm gonna loosen these about a quarter turn on each side. Whoops. That's better now. Yep, that motion's a lot better. We've got our light. We need our this piece, and where's the other? Where's the other clips? No, I had it. I probably knocked them out somewhere. Okay, I had more printed. Always print extras of small fiddly pieces. Get your light lined up in the printed part. Maybe easier said than done. Yeah, and they're sitting right there. I'm just blind. I think solder joint here, or the way the wires are routing, may be causing me some issues where it pops out just slightly. This is a sort of fiddly part here. Not bashing, just stating it is a fiddly part. It's a fiddly part, and it very, very, very much depends on your solder job as to whether or not this clips in very easily or not, and how your wires are basically bending, because damn it. It's so much easier if I had like crimped in connectors. Maybe that'll help. There we go. Once again, in my case right now, I'm just fighting the loops that I have in the wires. And because it keeps trying to twist the uh, the light itself out of the printed part. Work with your wires and snap it down on there. Bada bing, bada boom. That was way, way more difficult than it. Hey, Wondro, how's it going? Okay. You get good movement or good sound when moving it by hand. I'm going to bring my motor wires around here. That. Motor wire. I was like, why am I missing a... Okay. So as we've been doing, one at a time, we're going to test this motor out. We're going to connect up the ground wire first, so black to black. Red to blue, that's my signal wire. And we'll put a piece of tape on there. And we'll hit output. And nothing happened. So, ground to ground. Positive to positive. Oy vey. Got a motor, it's not working. Let's check a solder joint. Not good. And I guess while we're at it here, we've only got one more motor left. So why don't we physically try that? Yep, no, we'll have to solder that one back up. Ay, ay, ay. Soldering we go, soldering we go. Ugh. Now let's test our ability to pull this motor apart and see whether or not we're going to disconnect another LED light in the process. You stay over there. Oh, come on. Almost. There we go. Whew. That final bit, once it finally breaks loose, it's like, whoops. Okay. So it's quite possibly this, because I did not redo this side. Let's open this back up. Take this door off and we'll look at that solder joint again. Yeah, test saves time in the end. That is very true. Okay. Okay. Test this again. Negative to negative. Positive to positive. I'll put on. And still nothing. And oh, we're at 5 volts, 0 amps. 5 volt, 2 amps. Is it? Blue is positive. Negative down there. So it's in this solder joint right here, because doing the wire, it's not working, but doing it to the solder joint, it works. So that's still an issue right here with this wire. So this wire must be broken right here. We will just ensure that it is so now. Brush length the stripped wire. We will do what we can to clean up this solder joint and just clear some of the crud off of it. That's good. And this wire. Still a little bit of old wire there, causing this not to sit for. Tiny motors, tiny wires. Seriously? Okay. We'll try this again. Negative to negative. Positive to positive. Hold the motor up in case it moves. So is there a break in my blue cable period? Once again, if I clamp it on the stud, motor works. Now I'm wondering if the blue wire, it doesn't seem like there's anything wrong with it. We'll try one more attempt to touch it up, and then we'll just scrap the wire altogether. And because it feels physically attached. Okay, I think that just got all the old wire out. Now we're going to try one last time. That is physical good connection. The last time, if this doesn't work, then I will be grabbing a brand new blue wire, and we'll do it that way because it's running with ground, and when I connect to the positive terminal directly, it just won't run when I have it on the wire end itself. Yeah, it shows 5 volt 0 amp. I'm wondering if it might be the ferrule end even. It might just be the ferrule end. I will try that. In fact, what I'll do is I'll cut the ferrule off. I will strip some wire and try and go to the bare wire and see if it moves. If it does, then it was an issue with the ferrule crimp. Sometimes I hate these small, thin wires. It was a ferrule crimp. Dang it. We were going to check the other motor, but the other one we need to solder on as well. So we'll fix those. I need to grab my ferrule kit. We'd fix this ferrule. And it's almost 10 o'clock. Is Big Jono up and running? We're using the white ones, which are the smallest ones we've got. All right, sounds good, Wondero. I'm going to be calling it here soon as well. I'm going to be calling it soon as well. If I can get the fourth motor put together, that'll be it for tonight, and we will resume on tomorrow night or Saturday morning. We'll see how I feel tomorrow. All right, so that feels like a good crimp. We'll test that crimp real fast. And then we'll try and test the other motor before we build it all up. But I need to solder at least the connector back on. Yep, that was the ferrule side issue. Dang it. Okay, so this motor's good. Hopefully we didn't trim enough wire that it'll cause us problems down the road. Get my tie down put in here. Okay, so that's done. This back on. So we're 3 for 3 so far. Just took a little bit longer than we wanted to. But it's okay. I'd much rather it take a little bit longer and we ensure that this time when we go to close things up, that everything is right as rain. I have one more to go. There's 3. I'm going to need to redo the wiring on this one. Once again, y'all, I apologize because I know I haven't been talking as much and I know I've been a little bit focused, but this is fiddly time here and we want to make sure that we get this done right this time so we can put everything back together and not have issues. All right, now let's see if this motor works before we start trying to build things out, or if we have another issue. So we want black to black and red to red. If all works out, this motor is going to turn, and it does. So this motor is going to be good and will be good to go to plug it in. Plug it in, yeah. We will be good to go to build this last motor. So hopefully we can build this last motor and we'll have all 4 motors ready to go. And now I kind of know what I need to do for the other one, and that's potentially tear the tool heads apart, or the tool heads, the respoolers apart, but maybe not necessarily reprint all the parts. Maybe just reprint the parts necessary for that particular one. So we're going to start off by going to that side, and I do want to double check real fast that this is fully seated. Appears to be. So we go through the side piece. We get that pushed all the way in. We're going to push a wheel on or hammer it on, whichever way works. Here we go. We got it pushed on. We need to go ahead and put our spacer on. And it goes all the way up to make a nice good sandwich there. We've got our front piece that we've already put our bearing in and our magnet in. We need to put our motor in here now. Line that up with the grooves and just push it down in there. That in place, M3x8. Might be M3x10. I don't know what it calls for. That would require me to look at the thing. So we'll slide this down on there, making sure that our gears mesh like so. Whoops, before we do that, let's get our last LEDs or LED running in there. Now I'll set this down on there, mesh the gear. M3x8 on this side. We'll need to cable manage our wires here. Hey, Shrimp Father, how's it going? Are you just coming in for the night? We have been rebuilding Box Turtle. So we found several issues with my initial build. And once again, the blue and white one is the very first one that I built. And when I was building it, the 24 tooth gears, I actually reamed the holes out because I felt they were too tight of a press fit. That was a mistake. Partly because what I was hearing was the motor engage, but it would engage and run, but it's spinning the 24 tooth gear around the shaft. So that means it's useless. And then in the process of doing our troubleshooting, we determined that we had a couple of bad solder joints or broken wires, and I just had a bad ferrule crimp. So I had to cut the end off and recrimp a ferrule. But so far we're 3 for 3 and the motors are working. We are using a new 30 volt, 10 amp benchtop power supply here to test out the motors, which is really nice because I'm setting it at 5 volt, 2 amp, which is what we should be getting from the board. So all of these should work with the board, fingers crossed, once we put this together. Okay, so we've got the wire. I do need another zip tie. What did I do with my bag of zip ties? You know what? I have a feeling. I bet you where it's at is it's in the box of excess stuff that I put underneath the back of this. How much you guys want to bet that that's exactly where it's at? Oh. Oh wait, not that box. Not that box, but I do know the box that it's in. Box that has all the spare parts and stuff that I took back off out of here. That I need to put back in here before Mrs. Dragon gets home on Saturday. Because I really do want to get that other zip tie in there to make sure that that wire has proper strain relief, because those are very small wires. Now I've stumped myself because it was not. I mean, the box. I know the box that I'm looking for. The box was not where I was anticipating. Oh. It's where I put it. It just wasn't where I was looking. those. New ones. Sorry about that, folks. But the good news is I found my bag of zip ties. It's always good to have a bag of zip ties. And I found that the 4-inch size, what does it say? These are 4-inch outdoor cable ties. Wish I knew what, like the width of it. 4 inches the length. Oh, bag of 4-inch cable ties I got off of Amazon. Works well. Last side cover on. Making sure we don't mess up those wires that we just did. Go. M3x8. Lever arm. Yeah, that's clipping good. Let's go ahead and get our light. Play this game again, huh? It's we're gonna play the how the wire twists. That's the game we're playing. So the wire that I used is twisting my LED kind of out of position on the white part, which then makes it difficult to lever into blue part. Close, so close, so close. Ah, got it. Whew. All right, now we get the rear pieces lined up in the printed part. clips on there just like that. We put our other wheel on. And I think all four of our tool rewinders are now connected. I will need to take this part off, maybe take this first motor off a little bit. Hey, Big Jano, Royal Nomi, welcome on in, everybody. Holy crud, hold on one second. There we go. Big Jano rating in with a party of 25. Holy cow. Hey, Fox Waddy, or Wally. Foxy Owly. Sorry. Manor Mutant, welcome in. Royal Nomi. Big Jano. Da Vinci. Welcome on in, everybody. Thank you for jumping on in. We almost made the progress that I wanted to. We're getting close. What I had to do was I had issues in the respooler motors for my blue and white box turtle. Everything was working but these motors. I was getting frustrated, so we decided we were going to take it apart and disassemble it. I've reprinted all the parts. And the reason I needed to reprint the parts is our lanes are slightly different now. Okay. The way the lanes are and the way the extruders are. The original extruders. So these are the original extruder mounts. You'll notice there's 4 ears there for mounting it to the bottom of the lane. On the new version, there's only 1 on each side. So I had to rebuild these as soon as I printed the new lanes. Also, I reprinted the new lanes because rather than screws coming in from the side to hold your respooler now, your respooler is going to be able to sit right on here, and it's 2 screws from underneath that are going to hold your respooler in your lane, right? So this is going to sit in here like that. And there's 2 screws that come into the bottom that hold this. So if you ever need to work on your respooler, we're going to put some quick disconnect connectors in here. So we can just disconnect the connectors, undo 2 screws, and we can pop this module out and work on it. So the next thing that I've got to do is, and I'll probably do this off stream sometime tomorrow, is the LED wires that are connecting each side here. I'm going to cut them and I'm going to terminate them with microfit connectors so that they're plug and play. And that way I can take these 4 motors out separately. We'll still have the actual motors going into the MOSFET. I'm not going to mess with those right now. Every single one of these motors, I had to redo the solder joints because the wires broke at the solder joints just from handling them. And then this connector right here had a bad ferrule crimp that was causing this motor not to work at all. So, a few things, but every single one of these respooler motors is now working. We validated it using a 30 watt, 10 amp benchtop power supply. So we just set it to 5 volts, 2 amp, which is what we're going to get out of the Big Tree Tech board. So we'll be able to remove, I'll just desolder these or just cut it off, re-terminate these with JST connectors and get rid of the 2956 that we have here that we were using to test with at the last stream. And we should be back up and running with this once I assemble the frame. The big question is, I can simply take the existing skirts and reuse them. If I want to do the pretty honeycomb pattern in here, and I'm going to reprint skirts, if I reprint these style skirts, which are the slightly older versions, I'm good. If I reprint these skirts out of the brand new file set, from what I was told, the skirt thickness is a little bit different, which means I'd have to redo the hub, which means swapping out the, we'd have to swap out this part as well, which means we've got the end stop in here. We've got the 5 ECAS fittings. It's just, I think I'm going to keep this so that we can just build this in the frame and get it up and running. I know the bling is nice, but I need this one back up and running so I can tear down the heads on the other one and reprint all of these parts for the other one. The other thing that's different with these lanes is rather than having the sliders, we're now going to have rollers, and we've got scallop channels on it that your rollers will fit in. The nice thing is it gets rid of that piece, which honestly a lot of us had issues with it not locking in a specific position and then moving. And with the way of a spool, it moves it back. Now the spool's dragging across the bottom of the lane. And another good thing about that is these, let me grab one. So these idlers here, they use 608 bearings on this, one on each side of this center hub piece. Plus 4 heat set inserts, 4 screws to put this lower piece on to make it easier to print. It's a lot of hardware. We go to these. They are 3D printed in 2 halves. You have a 3D printed screw in a D shape that you just screw into the 2 halves. And then rather than using a 608 bearing here, we use more of the, these are MR 148 ZZ bearings. So these are the same bearings we're using on each side of the rewinders. So basically what this does is bomb simplification, because now you don't need 608 bearings at all. And you shouldn't need, you don't need 608 bearings, and you shouldn't need a lot of, you should not need as many screws or as many heat sets. And they've dropped the amount of heat sets like almost in half, which means you've also dropped all this, a lot of the screws that used to be used. So it's just a matter of picking up and moving it around based on the spool that you're using. A lot simpler, all 3D printed. The only hardware is the bearings. And I kind of like this setup a lot. And it's sloped inward, so it should fight the side-to-side motion that you get in your spools on like an AMS, which is a solid straight bar, right? So that's our roller bearings. Once again, these are all set and ready to go. I do need to work on putting in the quick disconnects, especially between the LED lights. And I also need to take the light out of the one and resolder a wire to it that broke. So, and then other than that, I think we're done for the day. I'm pretty exhausted. let's just say I did not adult well yesterday or last night or this morning, because an adult would have taken their happy butt to bed. But instead, the inner kid came out because, once again, it's been a long week, and he got hooked on Satisfactory last night. And next thing you know, he looked up and it was 6:30 a.m. And so he just stayed up all night. And that's about the time that Mrs. Dragon would have jumped into the stream, because she came over with Jano, and she just heard me admit that. But here we go. This is where we're at. I am going to call the stream tonight so I can seriously get in bed. The fixing the red and orange box turtle, I'm just going to start printing the parts, and I'm not sure if I'll do that on stream, because we have how many days left? Not many at all, between now and 3D Printopia, and I want to take at least those two. And if I can do it, I'm going to truly speed build a third one. So I will have 3 done before Earth. Stars aligned. Stars aligned. We've got a lot of learning done here. I now know how to solve several issues. I may, on the red and orange one, take apart, I may see if I can take apart the tool head, or the tool heads. I keep saying the tool heads, the respooler heads, and redo them. I think I can redo them without having to reprint all the parts and go to this new design and throw away a bunch of parts. And then the new, like the third new one I will build, will be all the latest and greatest version. So with that, normally I would be jumping over into Jano's stream, but Jano appears to be on my stream, so that's not going to work. Oh, and remember, in the words of Ivan Miranda, this, here, let me do it this way. This is not a hammer. So if you look at it, you can see all the dimples where it has been used as a hammer and a pen. This is a hammer, sort of. This is a 3-pound sledge. Works really great. Do not use this on your 3D printer unless you like mushrooming over your parts and then never getting bearings off of your steel shafts. Go out and get a dead blow. I've got this one, and I've got a fully, like, I'll say fiberglass nylon one. Go get one of these. This will help persuading some shafts with some percussive persuasion. Don't use a 3-pound sledge. Oh yeah, that's the other thing I have to do in order to build a third one, is I have to go out and cut some more frames, which I've got the stuff to do. Zombie streaming. Cool. Let's head over to Zombie then, folks. Yeah. Let's head over to Zombie. Thank you, everybody who was here for the stream and who's been here. I learned a lot, and I will say every single part of this was my fault. The reason these weren't working was my fault. It had nothing to do with the design. I could have made the old parts work. It was just easier to reprint to the latest version. So follow the directions, take your time. We all make mistakes. And now I've got, like a benchtop power supply, so I can test these things before it's fully assembled. And that's going to help out a lot. But thank you everybody for being here. Join me as we raid over to Zombie. I'm going to get some sleep, and then we're going to continue this maybe tomorrow evening, probably tomorrow evening, because I need to get it done. And I would really like to stream putting this one back together. So check for another stream tomorrow night, folks. Have a great night. Thank you, Longshot, for all the help you've done and helping me troubleshoot these things, and for recommending that benchtop power supply, because that worked like a charm today. So thank you, thank you, thank you. Everybody, have a great night. We'll see you tomorrow. Bye now.